We're all familiar with the sticky shed syndrome of certain videotapes and audio tapes of a particular vintage and particular brand. They can foul up the heads, they can cause the tape to start to screech, stick, and even completely stop. And the way to cure this is you have to bake them at a specific temperature for many hours to try to drive out the moisture. The machine I've used for baking tapes is a food dehydrator, and it's acting up. Let's take a look at it. I think everybody has heard the term baking a tape. That's what you do to a tape, be it a videotape or an audio tape that has developed sticky shed syndrome, where the tape will actually stick to the machine that's attempting to play it, be it audio or video. Tapes that were particularly bad were these Ampex 197. I think I showed this tape off in a previous video where it was actually physically sticking. This one, and I got a couple of others. Actually, I've got several that are in that state. And how we fix those tapes so that we can play them back is we bake them. And there's several ways to bake tapes. Some people just throw them in the oven, if your oven can be set cool enough, because you don't want to bake it too hot. Typically around 50, 56, 57 degrees Celsius, 135 in that range for Fahrenheit. And the easiest way to do that is with a food dehydrator. That's the simplest way to do it. What you do is you take your tape, in this case this one, you get one of these food dehydrators. This one's got a problem, I gotta fix it. But you take your reel of tape, in this case it's a 3/4 inch videotape, you put it in there and you bake it for 10 to 12 hours. And what that does is the warm circulating air that is generated in the food dehydrator, of course there's vents here, the air comes up circulating around the tape and gently warms it up to the desired temperature. And what that does is that drives moisture that has formed in the tape binder layer out. The problem that happened on all of these bad tapes is the magnetic layer was glued in place using a glue called a binder. And on several formulations of tape, that binder material was a polymer-based binder. And polymer will absorb moisture. And when it does, it starts to permeate through the tape coating and it gets sticky and it can stick to the internals of the machine, whether it's audio or video, and cause a squeaking sound, distorted video, distorted sound, and in worst case scenarios it actually stop playback completely. It will freeze and the oxide will actually start to come off the tape and stick on the machines. The Akai glass head reel-to-reel machines were really bad. They were probably the worst. And I've talked about that before, about how bad they are. You always have to bake tapes, especially for those glass head machines. Even at that, they're still hard on the tape. But I'm going to bake this tape, well, I'm going to bake it after I get this thing working properly. The problem with this machine is that the button to change the temperature is not working properly. You turn it on, starts out at the lowest temperature, but the plus button has a problem. Well, sometimes it works and sometimes it doesn't. So I'm going to see if I can, 58 is normally what I use because that's the next one up from 46, and then the highest one is 68. But we're going to pull this apart and see if I can fix that switch. That's also used once it gets up to temperature. You use that for setting the time too, because it defaults to 5 hours and you typically want to make it a little bit longer than that. So let's pulp this thing apart. We'll get a look inside it and see if I can get that membrane key switch to behave a little better. I'm assuming it's a membrane key switch. We'll just remove the screws that hold the top cover in place. The bottom cover doesn't come off, just the top cover. These units are pretty simple. They're just a heating element and a fan is all they are. But why these are desired over, say, using a conventional oven is because the temperature control is very accurate. You don't want it too hot because it'll damage the tape, but you need it hot enough to dry out the moisture. do have to lift this one off too. This top. So there's the heating element right here. And as you can see, the fan, when the air blows through here, here's the fan. When the air blows through, it causes the air to spin. So it's not coming straight out. That way it keeps the circulating of the, and there's a temperature sensor right here. Right? This is what makes them work. So a diode is used to detect the temperature, so you get very accurate temperature control. And that's why these are, say, more desirable than using other types of ovens. This is it's actually, it's not a membrane key switch. I thought it was a membrane key switch, but it's not. It's a, well, take a look. It's an inductive. So basically it detects your presence of your finger. So maybe this connection back here is not good. But because this just detects, there's no physical button. It just detects when you bring your finger in close proximity. So if something on here is not detecting, you see, it detects when you bring your finger into proximity. So if I bring my finger close to the start button, you see, it's not detecting. There, now it does. It's not detecting. Now what if I bring my finger right down close to this? Now it does. You see, so it's just it's not detecting here through the plastic. So if I get my finger close down here, it works fine. See? So it is detecting proximity, it's just not detecting it through here. And it's not much to it, it's just a little circuit board held in place with some hot snot. That's all it is. We'll pop the board out and let's see why it's not detecting. At least not through here. That's weird. Just peel the hot snot off a bit and I can slide this entire circuit board up. I wonder what that message is. I just got a message from a wrong number. Let's see what this says here. So I get this message. Is this Coach Andy? My daughter is coming over from China and she's very interested in tennis and I heard you're a good tennis coach. I'd like to ask you to be my daughter's tennis coach. Do I need to make an appointment? And I said, nope, not your wrong number. He goes, impossible. Aren't you Coach Andy? Or am I mistaken? It's like, no, it's like, wrong number, buddy. Here's my reply. I think you wing a wrong number. Okay, so that works. That works. So why is it not working on here? Maybe there's just some contamination on the plastic. I can't see that. How about the connections on the back? I mean, there's really nothing to it. It's just capacitively couples your body into the chip itself. So basically you're acting like an antenna, picking up induction from other signals, radio signals, electromagnetic fields. Your body is acting like a giant antenna, and when you bring it close to this, the signal transfers capacitively through the plastic into the chip and it can detect proximity. That's a proximity switch. Remember when I was in, like, I don't know, grade 8 or grade 9 or something like that, everybody was making proximity switches and nobody could get them to work. And everybody figured you would just hang a wire over your door frame and when you walk through it would turn the light on and off. And nobody could get them to work. So they all ended up on my desk for me to figure out what the problems were, and it was usually bad soldering on the circuit boards. But again, we're talking a bunch of kids in junior high school building these things and had no idea about electronics, and I don't think any of them were really interested in learning. A few of them were. A few of the guys built amplifiers and stuff, but I don't think too many were actually interested in learning about the electronics. They just did it because it got them out of a tougher class. They just did it to put in time. I'm just going to just resolder these connections here. I don't think that's a problem, but we'll just heat them up anyway. And then I'll reset it. Maybe it was just some dirt or something, or wasn't making a good. I mean, there's no connection here. It just picks up the signal. I mean, this is the one. Does it move? I don't think it looks bad. But I'll redo them anyway, just for the hell of it. Okay, I resoldered the contacts here, and I'll just put this board back in place now and see whether it responds any better. Goes in like this. Just like that. And the little temperature sensor just sat in here. The moment of truth. Is it going to detect the presence of my finger on the outside? Well, we'll find out. I would say that yes, it does. Now the motor will run for a couple minutes here just because there is heat that's been produced, and it has to monitor the temperature on here. But basically what happens is once you turn it on, once it gets up to the temperature, the display will change from displaying the temperature you've set it to displaying the time, and that's when you can set the hours. So everything's controlled from this little chip here. I don't think I need to bother putting any more hot snot on here. It's not going to go anywhere. A few other things to note on here. It does have a safety cutout down there. I'm keeping my fingers away from here because it's plugged into mains right now, but there is a safety cutout there so that if the fan were to fail, for example, and it were to get too hot, that would shut the power off to the heating element completely so that it can't overheat. So it's got a fail-safe on it. Not only the feedback loop, but that's in case something like this triac down here that controls it. There's an SCR that controls the motor, that turns power onto the motor, and then there's the triac here that operates the heating element. And of course there's another fuse. There's a 5 amp fuse over here. So everything is fused and protected. It's not bad. I don't see any bad quality in terms of construction on this unit. And now it's working, which is the whole plan, to get it going again. It was working, and say it just stopped accepting that input. So I figured it'd pull it apart. And looks like it was just maybe some debris, or it wasn't making a good connection. Now the fun part, getting the holes lined up. Put one down first as a pilot screw, and then the rest of them should all line up. So that tape I showed you guys a few minutes ago, I've already baked that tape. It was baked for, I think it was baked for 8 hours. So we'll try it and see whether it plays. I'll grab the machine and we'll set it up and see if it plays. And then I've got a few more tapes that I need to bake. But now this is back together. Daniels. And you can, the thing with these units is they typically come with multiple trays, so you can stack the trays and put more than one tape in it. You can put one tape in and then stack a tray on top and then put another tape in there. But there it is, the one tape. I turn it on and I select my temperature, 58, and I just let it go. And once it gets up to that temperature, the display here is going to change to the number, it'll say 05 for 5 hours, right? That'll go from 58 to 05, and then I can use the plus button here to increase the number of hours that it's going to cook or bake for. But now, at least when I put my finger here, it doesn't work. What the hell? It did. Now it's only turning down again. What gives? What gives? It was working and now it's not again. What the hell? Ah, the hell with it. Just stick a screw in there that's not quite long enough to make contact with it, but it's close enough that it now at least. So if I turn it on, this is what happens. I'll just set it for 35 because it gets there a lot quicker. Once it gets the temperature, this will be replaced by a time. Once it warms up, it defaults to 5 hours, and then you can just take it to however many hours you want. That's the maximum this thing goes for. It'll go for many, many hours. Up to a maximum of 48 hours. Well, obviously we don't need that. Typically, for doing tapes, we do them for around 10 hours. 10 to 12 hours is what the average tape is baked for, depending on how bad the tape is. So now this will run for 10 hours and then it'll shut off, and then when it shuts off, it will go into a cool down state, where it'll cool it down. And then you can try your tape and see if it plays any better. And if it plays, great. Otherwise, sometimes you've got to do it more than once. But this is what I've been using to bake tapes. I've had pretty good results with it. I picked this thing up used for a song. They go for, I don't know, 70, 80 bucks for a new, something like that. But you can get them always used for 20 bucks or less. Some of them don't have temperature control though. So if you're looking to buy one, make sure that you find one that's got a temperature control. Some of them are preset for like 68. Ones that are made for meats and beef jerky and stuff, a lot of them are preset for 68. You really want 58 Celsius or 57, which is your 135 to 137 range. That's typically where you want to do your tapes. Anyway, hope you found this one useful. Thanks for watching. And there's the tape after baking that would not play before. I'm going to let this tape play all the way through and see if it plays through. But yeah, this tape would not play prior to baking this tape. It was just screeching and stopping and just would not play.